Students, welcome once again to the Owl Academy of Education. In today's video, we will learn about chemistry, ICSE Class 7, chemistry subject, lesson 4, that is atomic structure. Now, the first thing that is required here is the lesson is atomic structure, so we will start from the atom. Now, what is atom? An atom is the smallest particle of an element that takes part in a chemical reaction, right? All elements are made up of atoms. You can understand atom from the model of a building. That is, our houses are made of bricks. Similarly, all elements are also made up of atoms, right? And this atom is the smallest particle of the element, and this atom is that part which takes part in the chemical reaction. All elements are made up of atoms. Now we will learn about discovery of the atoms. As discovery of the atoms begins from India. Which was the first Indian philosopher Kanad. One of the first person to propose that matter is made up of very small particles. Here he gave these atoms the name Parmanu. Now, when Kanad defined the atoms as Parmanu, then all the chemists of the world started to discover in this way, right? Later on, John Dalton was the next. He, instead of saying them Parmanu, he gave these Parmanu his own name called atoms. Right? Actually, meaning of this word atom is indivisible. Indivisible. That cannot be further divided, so they are indivisible and they are called atoms. Now, inside these atoms, there are present a variety of more tinier particles called subatomic. Subatomic particles. These more tinier, more smaller particles were called as subatomic particles. Right? Here you should know one more thing. Instead, you must know one more thing. Now, these atoms joins together to form what element. Now this joining can be of similar particles or different particles, right? Similar elements or different elements. Now if same kind of atoms joins. Now if say what is this same kind? Same kind, as we know, oxygen is O2. How this happens? When two atoms of oxygen joins together, they form this, or they are similar in the same way. When n plus n happens, same kind of atoms of nitrogen, then we will get nitrogen. This is oxygen, this is nitrogen, right? So here same kind of atoms joins. They are called homoatomic substances. So how we will define them? We will define them here: homoatomic substances. If same kind of atoms joins together, they form homoatomic substances. What is example? We will give here example: O plus O equal to O2, N plus N equal to N. This way. Now when same kind of atom joins, they form homoatomic substances. If different kind of atoms can also join, they will be called heteroatomic substances. From here, this definition, if we will remove the word same, if different atoms join together, they form heteroatomic substances. So they are also abundant. First is our lifeline. First line was lifeline was oxygen, same kind, found by same kind of atoms. Now second lifeline is water, H2 plus O. Then water, this is water, right? C plus O2, CO2, this is carbon dioxide. Etc. Right, students? Mother Nature has given us O plus O, same kind, O2, oxygen, we breathe. Different, H2 plus O, hydrogen plus oxygen, we get water, or C plus carbon plus oxygen, we get carbon dioxide. So they are abundant by mixing, whether it is of same kind or different, homatomic or heteroatomic. Right? Now, one important thing you should know, that these atoms do not exist independently. Right, students? They always combine with other atoms to stabilize them. Right? So they always combine together to stabilize them. They may combine with same homatomic or different heteroatomic. Right? Now, what will these linked atoms are known as? Joined atoms are known as? They are known as molecules. Right? When atoms join together, they form molecules. Right, students? So here we got definition of molecules. Right? Molecules example is oxygen, nitrogen, water, carbon dioxide, etc. Right? Now, we have learned that atoms do not exist independently. There may be exceptions, there could be exceptions, because exceptions are always there in the world. Right? So, some stable atoms some of the stable atoms has the power to remain in isolated form. Right? Like example is neon. Neon is so stable that it can remain in the isolated form. Right? Now if we want to understand the joining of these atoms, We can take one example of ball and stick diagram. How they exist? They joins by bond. These are called joint or bond. Right? Now, if we join here, we draw smaller circle. Join here, draw smaller circle. These big circles are one kind of atom. These big one kind. And these two small are called another. Atom. Right? They can be understood by this model. This is called ball and stick diagram. Right, students? Now, we will move to inside of the atoms. Is there something more inside of these atoms? Now, yes, as we know, atoms are main building blocks of matter. Atoms are main, in fact, rather we will say the main building blocks of matter. Whole matter is made up of atoms, so they are called building blocks of matter. Now, there may be more tinier particles in the atoms. They are called subatomic particles, as I have told you earlier. Now, these is there name of these, any name for these subatomic particles? Yes, they are number one protons, second one is neutrons. Right, students? Now, these are present inside the atom. That is in the central part. These are present inside the atom, that is in the central part of the atom. There are one more particles, they are called electrons. Right? This central part is called nucleus. Main thing is, in the nucleus, the central part of the atom is called nucleus. In the nucleus there are protons and neutrons. Right? Protons and neutrons inside the central part, which is called nucleus, and electrons are situated outside the outside the nucleus, right? Electrons are present outside the nucleus and they revolve around the nucleus, right children? Right? So how we can draw an atom, structure of an atom? Suppose this is central part. Here are protons and neutrons, right? Around these revolve electrons. They are called electrons. They are always negative, right? So this is central part of an atom. Here this is nucleus. In the nucleus there are proton and neutrons, and around the nucleus revolves electrons, right? Now these electrons revolve in definite orbits. These are also one orbit, second orbit. So these orbits are known as energy shells, right? Each energy shell has its own energy. They are energy shells. This is the thing that will disturb you in the whole chapter, so it is advised to understand it carefully. Inside the atom, that is in the central part of the atom, which is called nucleus. Central part of atom is called nucleus. In the nucleus there are present protons and neutrons, right? This nucleus, proton and neutrons. Now around this nucleus revolves electrons in different orbits, right, having its own energy, and these orbits are called energy shells, right? Now here we have understood proton, neutron and electrons having different energy shells. Now from here onwards we will deal with some definitions. First of all is atomic number. Now atomic number, it is the number of protons present in the nucleus of an atom of an element. Important thing, atomic number, it is the number of the protons present in the nucleus of an atom of an element, right? It is represented by Z. We represent it by Z. So here we can say atomic number which is represented by Z is equal to number of protons Here you have to remember one thing, which is I am representing with here the star. Number of protons, proton is always equal to number of electrons, right? Atomic number is number of protons. Number of protons is equal to number of electrons. Now why I have given it star? Because atomic number cannot be the number of electrons why? Because the number of electrons change during the chemical reaction. So that's why atomic number cannot be the number of electrons, right? Now because number of proton is number of electrons, because number of proton is equal to number of electrons, therefore the atom is electrically neutral. Here the word electrically neutral has been used. So what is this? Electrically neutral means the electrically there are two charges, positive and negative. The thing neither containing positive neither negative, equal number of protons and number of electrons are equal, here it becomes electrically neutral, right? So number of positive charge here becomes equal to the negative charge. Proton always positive, electrons always negative. Proton always positive, electrons always negative. So when number of proton is equal to number of electron, we say that number of positive charge is equal to the number of negative charge. So when positive and negative are equal, the thing becomes electrically neutral. Here, this is the meaning of electrically neutral substances, right? So this was atomic number. Atomic number is number of protons. Protons are positive, electrons are negative. When number of positive charge is equal to number of negative charge, the substance becomes electrically neutral. Or number of proton is equal to number of electrons, the substance becomes electrically neutral. Number second thing we are going to deal is mass number. Now mass numbers. Earlier I have told you about the nucleus. Nucleus is carrying proton and neutron, right? So the total number of protons and neutrons inside the nucleus of an atom is known as mass number. Mass number is represented by A. It is represented by A. Atomic number is represented by Z. Atomic number is number of protons, whereas mass number A is total number of protons plus number of neutrons inside the inside the nucleus. Okay? Right? Now this mass number is also called or atomic mass. Mass number or atomic mass of the atom. So therefore mass number or atomic mass A equal to number of proton plus number of neutron. Right? Now I have told you earlier, oxygen is made up of two similar particles, that is O and O. So it has 8 protons, 8 neutrons. That means this O2 has 8 plus 8, 16. So its mass number is 8 protons plus 8 neutrons. 8 protons, 8 neutrons, so its mass number becomes 16. Right? In the same way, sodium has 11 protons and 12 neutrons in the nucleus. Its mass number is 23. Right? Now we have learned about mass number. In the same way, we have to learn about relative atomic mass. Relative atomic mass. So it is the number which tells how many times an atom of that element is heavier than an atom of hydrogen. So students, relative atomic mass is the number which tells how many times an atom of that element is heavier than an atom of hydrogen. So what does this mean? Here I am going to explain it further. Suppose as we know, atomic weight of nitrogen is 14, and atomic weight is 40. What does this mean? This means that one atom of nitrogen, one atom of nitrogen is heavier. How much heavier? Is 14 times heavier than one atom of hydrogen. It is 14 times heavier. Nitrogen is 14 times heavier than one atom of hydrogen. So the relative atomic mass is the number which tells how many times an atom of that element is heavier than an atom of hydrogen. Right? And atomic weight, because atomic weight is in ratio, therefore it does not have an unit. Right? Now, students, if we proceed or go further in this chapter, we will learn about arrangement of subatomic particles in atom. This is very important, arrangement of subatomic particles in atom. Arrangement of subatomic particles in atoms. How subatomic particles are arranged in atoms. Suppose we will take example of oxygen. Now, oxygen atom has 8 particles. In the first cell there are 2, in the second there are 6. Right? Now, number of protons is equal to 8. Number of protons is equal to 8, that is its atomic number is 8. Right? Number of electrons is also 8, and number of neutrons is also 8. So total number of protons and total number of neutrons is mass number. So its mass number will equal to 8 plus 8 equal to 16. This is mass number or A, or atomic weight, atomic mass. Number of only protons is Z, atomic number. Right? If we want to draw its configuration, of what? Oxygen. This is its center part. It is containing 8 protons, 8 neutrons. We will make this work bigger. This is proton equal to 8, neutron equal to 8. Right? Now, how we will show these protons and neutrons? In the first cell, only 2 electrons. Negative means electrons. All positivity is here in the nucleus, and in this shell we can show 6. There 1, 2, 3, 4, 5, and 6. This is the atomic structure of oxygen. Right? So now how is this arrangement made, on the basis of which, right, how this electronic configuration has been arrived. So this electronic configuration, model of this electronic configuration was given by electronic electronic configuration, arrangement of particles in a atom was given by Niels Bohr. Who was Niels Bohr? He was a Danish scientist, right? He was the first person to give the idea of electron shells and told that each shell can hold a limited number of electrons, right? He gave the idea that each shell can hold a limited number of electrons. Suppose this is the nucleus. Here all protons, neutrons, that means all positivity is here. Nucleus excluding this is nucleus. Here all positivity is proton in the form of protons and neutrons. From this is the first shell, this is the second shell, and this is the third shell. Right? Now this is first shell. This is second shell, and this is the outermost third shell. Excluding nucleus, this is nucleus. Excluding nucleus, there are 3 shells, first, second and third. So this first can hold only 2 electrons. Second shell can hold only 8 electrons. And third is 18 electrons. So this is the electronic configuration or electronic arrangement given by Niels Bohr. So you can easily learn from here that how we have made arrangement of electrons in the oxygen atom, right? This is the nucleus of oxygen. This is containing 8 electrons, 8 neutrons. No, sorry, 8 protons, 8 neutrons. Now we have to make arrangement of 2 and 6. So first cell we will take here 2 electrons, 2 electrons, 1, 2, right? 2. Now remaining 6 can be, we can move on to the next, which can hold 8 electrons. Here 6, 1, 2, 3, 4, 5, 6. These are all negative. Negativity means electrons. Right? This is arrangement for oxygen molecule. Arrangement of electrons for oxygen molecules. If we want to understand it further, we can take one more example, that is of sodium. Sodium atom. Right? Sodium atom is having mass 11, atomic mass 11. So what will be its arrangement? We know that in the first cell there are only 2. In the next cell we can arrange 8. In the next cell we can arrange 18, yani 2 plus 8, 10 gone. Only 1 will be in the third cell. Right? So its electronic configuration would be, this is nucleus, proton equal to 8. Now we have to make arrangement of proton equal to 8, neutron equal to 8. We have to make arrangement of electrons. Electrons, 1 electron, 2 electron. Okay. Now 8 is full in the next cell. 1, 2, 3, 4, 5, 6, 7 and 8. And one more is left in the last cell. Right? So the first cell was that means this cell is given K, this is L and this is M. In K 2, in L 8, in M 1. 281 is the mass number of sodium. Right? So students, this was first part of your fourth lesson. Now we will move to the next in the next video. Till then, it's goodbye. If you like the video, please share and subscribe our channel. If you have any query regarding this, you can go to comment section of our channel and ask your questions. Right? It's goodbye. till the next video. Enjoy the lockdown by doing your homework from our videos. Subscribe our channel and get it subscribed by your other friends too, so that they can also be helped in doing their homework. So it's goodbye till the next video.